So it's a great question about whether these injuries are related between football and the blast injury. And indeed, if we look at the neuropathology, the human neuropathology, the pathology is indistinguishable. And that makes sense because the injury mechanism that we've uncovered here really is identical. The difference being this: in football or in hockey or boxing or other types of contact sports, the inciting injuries seem to be linked to repetitive traumatic injury, whether it be concussive or subconcussive. So that if there's a vulnerable period after an initial trauma where the brain is trying to resolve the initial trauma, and if there's a second hit in that period of time, the brain is particularly vulnerable and may then be really primed for a sustained, long, chronic course. This is still somewhat, it demands more experimental evidence, but that a lot of people are thinking that, including myself. I think that's right. What happens in blast is that we see multiple injuries very quickly over a period of milliseconds. So when I say that the head is bobbling or oscillating, this can be between 4 and 14 different movements over a period of 3 to 8 milliseconds. So that if we think about repetitive injury on the football field being, happening one day and then the next day, and maybe another one the next day, this is being compressed now into milliseconds. Damage, 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 damage. And that's why we think that one exposure may be in some ways a compression of multiple injuries. So from that perspective, in many ways, the blast injury is another way of impacting the brain and traumatizing it. It's not fundamentally different from the standpoint of physics from what happens on the football field.